I will be going over problems 21 through 25 of the math section on practice test 2 in the ACT practice booklet. So problem 21 says, a park has the shape and dimensions and blocks given below. A water fountain is located halfway between point B and point D. Which of the following is the location of the water fountain from point A? Note, the park's borders run east to west or north to south. So I'll just put an arrow for north there. So first I just draw where I think the water fountain would be. So because it's halfway between point D and point B, it has to be somewhere on this diagonal here because it has to be halfway between this way and halfway between that way. So first next I'd look at these distances here. So this distance here, because this is 12, you know that this also has to be 12. So 12 minus 3 is 9, so you know that this has to be 9. But you're trying to find half of that because the water fountain is halfway between these 2 points. So half of 9 is 4.5, so you know that this here must be 4.5. So therefore, from point A, you know that you have to travel along here and then travel 4.5 blocks north. So next I would look at what this distance would be from point A. So to do that, I'd first find this up here, which we know would be 3 because this down here is 10 and 10 minus 7 is 3. So, and then the water fountain is halfway between that, so that would be 1.5. And then from here, you know that this down here would be 7 from this up here also being 7. So 7 plus 1.5 is 8.5. So from that, you know that you must travel 8.5 blocks east and 4.5 blocks north. So the answer for this problem is D. Okay, moving on to the next problem. So the next problem says, the braking distance, y feet, for Damon's car to come to a complete stop is modeled by y equals 3 all times x squared plus 10x, all divided by 40, where x is the speed of the car in miles per hour. According to this model, which of the following is the maximum speed in miles per hour? So I would just use my calculator for this problem, so I'm just going to put it below the screen here so you can see it. So I'd turn it on, obviously. And then I'd go to y equals 3 times x squared plus 10x divided by 40. And then what I do next is I'd hit second and then go up here to this button to table. And I would just check the values that they have. So the first one is 10. And so that doesn't equal 150, so it's not that. Then 30, which also doesn't equal that. And then 40, which does equal 150. So you know that the distance that he travels has to be greater than 150. So the braking distance, so the speed that he's traveling in miles per hour must be less than or equal to 150 feet. So moving on to number 23. Sorry about the phone. If f of x equals x squared plus 5, if f of x equals x squared plus x plus 5, and g of x equals the square root of x, then what is the value of g of 4 divided by f of 1? Okay, so g of 4 would be the square root of 4 because you just would plug this value into wherever x is, and then f of 1 would be 1 squared plus 1 plus 5. So g of 4, so the square root of 4 equals 2, and this would equal 7. So therefore g of 4 over f of 1 would equal 2 over 7, which is A. Okay, moving on. So next is problem 24. At a school picnic, one junior and one senior will be selected to lead the activities. If there are 125 juniors and 100 seniors at the picnic, how many different two-person combinations of one junior and one senior are possible? So this is just some basic probability. Whenever it asks you for different combinations in these problems, a general rule that I like to use is that you usually just multiply the two numbers that they give you together. So in this case, you'd multiply 125 and 100, so that would equal 12,500, which would be K. Okay, now for problem 25. So 25 says that the scatter plot in the standard xy coordinate plane below contains data points showing a strong linear correlation between the variables x and y. Mia drew the line shown to model the data. One of the following equations represents Mia's line. Which one? So, first of all, I would look at the graph and see what the y-intercept would be, because usually for these linear correlation problems, you'll want to write the equation of a line in slope-intercept form. So y equals mx plus b, where m is the slope and then b is the y-intercept. So just from the graph that I'm looking at here, it looks like b equals 10. And so then the next thing that you need to do would be to find the slope. And generally for this, you'll want to use the 2 points kind of on the end of the graph with the y-intercept, just because it's just a little bit easier. So the 2 points that I would use would be 0 and 10. And let's see, there's one that goes like right through a line really close to the end, so I'm going to use that one. And 3 and 1. So then the slope is m equals y2 minus y1 over x2 minus x sub 1. So these are just, you subtract the y values and then put that over the difference in the x values. So here that would be 1 minus 10 over 3, which equals negative 9 divided by 3, which equals negative 3. So from this, you can see that y equals negative 3x plus 10, and it looks like that would be B on the answers. So just some techniques from this video would be a useful technique that I like to use for problems where they give you an equation and ask certain questions about it, like number 22 about the braking distance, is I like to just put the equation into y equals in my calculator and then just use the table to check the values that they give you, because this is just a lot faster than plugging them in and just plugging them in your calculator through that. And then another tip that I would say is when they give you these diagrams, like in the first problem about the park, it's just useful for me to label things that I know in the diagram. Like, here, I'll put it back. Like, in this diagram, I just went through and labeled the distances that I could find, and that really helped me get to the right answer. Okay, that's it for today.